Today, we're going to pull back the curtain on a hidden structure that, well, basically runs our entire world. It's a concept so fundamental you use it dozens of times a day without even thinking about it, from sending a simple text to waiting for your morning coffee.
So, let's kick things off with a little puzzle. What on earth do these three things have in common? Now, the answer isn't a punchline. It's actually a really simple, elegant idea that brings order to chaos in, well, pretty much everything we do. The answer is the queue.
To really get our heads around how queues work, we have to start with something we all share: waiting. I mean, nobody likes it, but you just can't escape being in a line.
Just think about it. You see these lines absolutely everywhere, and they all operate on this deep, intuitive principle of fairness, right? The first person to get there is the first person to get help. It's this simple social contract we all just get.
Okay, so we have this intuitive rule, but let's give it a more formal name, because taking that simple social idea and turning it into a technical structure, that's where the real magic happens.
See, in computer science, a line is called a queue, and its core principle is FIFO, which just stands for first in, first out. It's just a techie way of saying what we all know from the grocery store. First person in line is the first one to the checkout. Simple. Fair.
And here's the beautiful part. A queue really only does two main things. You NQ to get in the back of the line, just like stepping in behind the last person. And you DQ when it's your turn at the front and you get served. That's it. Add to the back, remove from the front.
Okay, but here's where things get really interesting. That simple, fair line, it's not always the best solution. As it turns out, not all queues are created equal. Different problems are going to need different rules. So you have your simple queue, like at the supermarket, totally fair. But in a hospital emergency room, you definitely don't want the person with a paper cut going before someone who's having a heart attack. That's a priority queue. It serves the most critical task first, which means it trades a little bit of that pure fairness for life-saving efficiency.
And we can get even more clever. A circular queue, for instance, loops back on itself to reuse memory. Your computer's operating system is doing this constantly. Then you have the deck, or double-ended queue, which lets you add or remove items from either end. It's kind of like a line where people can jump in or out from the front or the back, which is super useful for solving certain complex problems.
Okay, so let's bring this back to the real world. Specifically, the technology you use every single day, where these queues are working silently in the background, just making your life easier. I mean, every time you send a job to the printer, it enters a queue. When you've got 10 tabs open, your computer's CPU is using a queue to figure out what to do next. And you know how a massive website can handle millions of requests without crashing? That's because a queue is acting as a load balancer, carefully feeding requests to the servers one by one so they don't get overwhelmed. They're literally the invisible traffic cops of the digital world.
Now, what makes queues so incredibly powerful in tech is their speed. In programming, we have this thing called Big O notation. A well-designed queue operates in what's called O of 1, or constant time. And all that really means is that adding someone to the line or serving the person at the front takes the exact same amount of time. It doesn't matter if there's one person in line or 1 million. That mind-blowing efficiency is why they're the backbone of so many things we use.
You know, this whole concept is so fundamental, so absolutely crucial to making our world work, that there's an entire field of mathematics dedicated to studying it.
It's called queuing theory, and it's basically the science of not waiting. This field lets us analyze and actually predict how lines will behave, how long they'll get, how long the wait will be. It's used to decide everything from how many cashiers a store needs to how many servers a data center requires to keep things running smoothly.
And this is not some newfangled idea. It actually started over a century ago with a Danish engineer who was just trying to solve telephone call congestion. His work on managing those phone lines laid the foundation for everything, from the early internet all the way to the massive cloud data centers that power our world today.
So, if you remember just one thing, let it be this. Queues are a simple, elegant, but profoundly powerful tool for managing limited resources. They take a situation that could be absolute chaos, everyone trying to get something at once, and they transform it into a structured, predictable, and often fair process.
So we'll leave you with a final thought. Now that you can see these hidden lines everywhere, think about a system in your own life that you could improve. Would you go with a simple, fair queue, or would a priority queue be more efficient? The power to bring order to chaos, it's all about understanding the line. Thanks for joining us.